This is a moisture investigation that I just completed on this house. The homeowner reported experiencing water running down the inside of the ceiling whenever the temperatures were below freezing for a while and then got above freezing or the sun came out. The suspicion at the time was that the moisture was accumulating inside of the roof, and then when it was warm enough, it would melt and then release as liquid. This mudroom area that I just pointed to was the initial major point of contention. There was a lot of staining on the wood above this door as well as on the floor. I measured the wood moisture content to be 15%, which was drier than I suspected, but it had been cold for a while, so the moisture hadn't released in a few days. Based on the pictures that the owner provided, as well as what I could observe inside of the house, here you can see the polyisocyanurate. The way the roof was constructed was there was a steel roofing, synthetic underlayment, OSB roof sheathing, and then air gap, multiple layers of polyisocyanurate insulation that were foamed, and then the pine ceiling underneath. The suspicion here was that the roof was not airtight and it was allowing warm, humid air to go up inside of the roof assembly into that air cavity, but that the air cavity was no longer ventilating. This is a smoker, and this is the condition we had before where the smoke was not going up inside the soffit. This is one of the initial tests I did, and the point of this was to determine whether or not there was adequate ventilation going into that air channel, and it indicated that it was not working properly. There's the main living room. This is a light socket. There's the polyisocyanurate we saw from up top. It is foamed here, but it wasn't foamed on the other sections of the roof. So we're testing the pressure of the house inside relative to the outside by using the probe under the door. And it's negative 2 to 3 pascals, so the house is depressurized slightly because of the wood stove. The house was using a wood stove as its main heat source, and that depressurization of the house was causing the house to be very dry. So they provided supplemental humidification, and most of the humidity was around 40% throughout the house. This is some thermal imaging of that mudroom where the leak was. And the point of doing this was to determine a baseline. Later on, we'll do a blower door test and take these same images and see the difference. So we'll be able to see where the air leaks are. But this just gives us an indication as to where the cold spots are at this time, and then we'll look at it again later. This is the same baseline. This is in the living room area above the kitchen. This is the ceiling fan in the living room. This is, again, just to give us a baseline to determine if there's any cold spots prior to blower door testing.
Early this morning,
And that one there is pretty even, not a lot of cold spots. This is the second floor loft area. Went around looking for cold spots just to be able to compare later on. And over here by the fireplace, where the chimney goes up inside, you'll see it's warm there. That's a pretty bad spot later on. All right, running the blower door now. We got a reported value of 14 to 1500 CFM. I believe the air change per hour was over 4.5 air changes per hour. So then we're going to go through and look at the ceilings again with the thermal. Now this is an image of the ceiling in the mudroom while the blower door is running. You can see all of the blue lines, and now this was before and this is after. So all of those blue lines are indicating cold air pouring into the ceiling, and that air leakage when the blower door isn't running means that the hot, humid air is moving up inside of that roof, hitting a cold condensing surface, turning to water, and then when it's warm enough, that ice and water turn to liquid and run down inside of the ceiling. The living room ceiling was much more airtight. However, there was one major hole up near that fan, and that's where the homeowner indicated that a leak had previously occurred. This is the second floor kind of attic area with a dormer on the back. That hole right there on the right was the where that light fixture was removed. You see that right in front of us is the where the stack pipe went through the roof. There's a lot of leakage around there. But the main ceiling, the body of the main ceiling was much better than the mudroom. There's some corners, and especially near the ridge, that leaked a lot. So this corner on the road-facing side was pretty leaky. And then the main body of the front roof looks pretty good, but up near the ridge, there's a lot of leakage there. And that could be problematic when the warm, humid air moves up inside of it. So this is another spot that was very cold, and there's a lot of air turbulence there, indicating that there's quite a roof leak right up here. Because normally, if this smoke is pretty steady, if you put it against a surface, but up here you can see how much turbulence is there, demonstrating the airflow. Coming in, so 60 degrees on that surface. And then there's a big air leak near that cap. All right, so I'm at the chimney in the living room here. The house is currently depressurized to negative 50 pascals of pressure. There's a 52 degrees right here on this surface, indicating a big air leak. And I put the smoker in here, and it's quite the airflow. You see, it's just blowing really hard right here. So there's quite a bit of CFM loss there. So when the house isn't depressurized, the hot, humid air is moving up inside of here. And if that ridge isn't vented, you pull out that moisture, it's going to condense inside that roof assembly. This is a light that's popped out there, and when I put the smoke up there, it's pulling right in. So that's indicating that there's airflow coming from behind the ceiling, obviously, and it's coming from up inside that roof assembly, which further demonstrates that that insulation isn't airtight enough to control the condensation.
All the way across?
Yeah. Yeah, so this is the synthetic underlayment that is covering the ventilation channel underneath. 26% wood moisture content on the ridge. You can see all the ice forming up here. So this was sealed up, and all of the airflow was accumulating in this air gap because this isn't airtight, and the foam doesn't touch all the wood. So any airflow in there carries moisture, touches the cold surfaces, and it's iced right up. So this is going to be in the whole way. You can see ice formed on all of the surfaces, including the top side of the insulation, which is interesting. So there's a lot of moisture accumulation at the ridge. I suspect that when this heated up during sunny days or whatever, it would melt all of this ice, and that moisture would go back into the warmer air. It would condense and then go down into the ceiling, because this is all open. I can almost see the bottom of the ridge because it's not tight. All right, so still cutting this out, and there's liquid water on here, and it's 20, 22, 23 degrees out, I think, right now, which indicates that there's still a lot of excessive moisture moving up through here. Excuse me, temperature and heat flow moving up through here, because otherwise this would be frozen. All right, here we can see there is an air gap underneath the sheathing there. That frosty layer is the sheathing. There is a gap underneath it, which means that this should vent. When we put this ridge cap back on, this should vent fine. And it should carry enough moisture, it should carry enough heat flow and airflow to dry all this out. But right now this ridge is at 26% wood moisture content, and this would have rotted out in just a few years if left in its current condition. This little stick right there at the tip of my finger is the piece he used to hold the insulation down. So I'm confident that there's enough space there. It looks like a 1-inch gap. So there should be plenty of airflow to help dry this out. And this is after we opened up the ridge. You see the difference. It's blowing around, but that's completely going up inside. It's not coming back out at all. So obviously the issue with this house is that moisture was accumulating inside of the roof assembly, And the question is whether or not this is a moisture related issue, like the humidity was inside was too high, or whether or not this is a ventilation issue and there was not enough ventilation. So the argument could be made that the moisture in the home was too high, and I did data log for over a week, the temperature, humidity, dew point, etc. And it has higher than average interior relative humidity, but it's not out of the question. It was around 40% relative humidity, and the house was very leaky by evidence of the blower door score and the tracking the CO2 dropping very quickly. The natural ventilation in the house was pretty high. So if there was no excessive moisture in the residence, then there would be less moisture accumulation in the roof. And if the roof was ventilated, there would be less moisture accumulation in the roof. So if there was no moisture in the house, it wouldn't be a problem. And if it was well ventilated, it wouldn't be a problem. So the question is, at 70 degrees and 40% relative humidity, is that unreasonably high of a humidity level to be expected in a newer home? And I don't think it is. All right, got the ridge back on, and it should be all set now with that ridge open. Still got to do this one once the weather gets a little better.